Alright guys, welcome to today's distance learning day. What I'm going to teach in this video is everything that we would have typically covered if we met in person today. So the first thing is underneath this video, within the same assignment, you guys can grab this note sheet, standard form of a quadratic. Today we're going to talk about standard form. This worksheet, we're going to do some of this throughout the video, so it helps if you have two screens and you can watch the video on one and take notes on the other. That might be the most effective way to do this. But today's idea is to look at a different way to write a quadratic equation. We talked about vertex form last class. Today we're talking about standard form. Standard form is this equation right here, y equals ax squared plus bx plus c. What you should notice is this form doesn't have any parentheses. It does have an a value, it does have a y and an x value, it does have a square. The only difference is now we have another term that has an x value, and then we have two different values, b and c. So the goal is to figure out what each of these values does to our quadratic equation. So I'm going to flip back and forth between two screens here, but notice how I have the sliders turned on for ax squared plus bx plus c. And if the a, b, and c value are all 0, notice how we get a flat horizontal line. That's because our a value is 0. So one of the things I'm going to add to these notes is that a cannot equal 0. If it equals 0, we don't have a quadratic, we have this. So I'm going to make our a value 1. And this would be y equals 1x squared plus 0x plus 0, which would just be our parent function. So we've talked about this in depth before we even started vertex form. So the first thing I want to talk about is the a value. Notice how anytime the a value is positive, the graph is always opening up. But when we flip it to make it negative, anytime our a value is negative, we have a graph that opens down. So that's going to be the first thing I have you guys write down. That's the same as what we saw before. So if a is greater than 0, we have a graph that opens up. And if a is less than 0, we will have a graph that opens down. The next thing is concentrate on when the a value gets greater than 1, what is happening? The graph is closing, right? It's getting more narrow, which means it's a stretch. However, when the a value is between 0 and 1, it's getting wider, okay? So our rules for a, our notes for a are the same in standard and vertex form. So if the absolute value of a is greater than 1, we're going to have a stretch. And if the absolute value of a is greater than 0 but less than 1, we're going to have a shrink. So it's nice that a works the same in both standard and vertex form. So now it's what does b and c do to our equation? So if I keep the a value at 1 and I just start changing this b value, when I start to make it positive, notice how the graph's kind of doing two things. It's moving not only left, but it's also moving down when I make the a value positive, or the b value positive. And when the b value gets negative, notice how it's moving right and down, okay? Notice how every time I change this b value, the y-intercept is staying the same. Do you notice that? This point right here, this y value, is always staying the same. No matter where the graph is, the y value is always the same. That's because of the c value. So look at what happens when I start to change the c value. See how the y-intercept changes? And even easier, see how if I leave it here, the c value is at -5. Look what the y-intercept is, 0, -5. What happens if I make it 3.5? Well, it's at 3.5. Even if I change the a value, change the b value, and leave the c value alone, notice the y-intercept is still 3.5. So the next note, and probably one of the most important, is that 0, c is the y-intercept. This is going to be something that's really important in standard form. It's actually the only point that we can get without doing any work. So in vertex form, if you remember, we could look at the equation and know what the vertex is right away. It was h and k. In standard form, you can't find the vertex right away, but you can find the y-intercept. Now, the hardest thing is to figure out the vertex, and it kind of takes some work. The vertex, it would take a lot of examples to show you, but if I make the c value 2 and the b value -1, and let's say the a value +1, the vertex is at 0.5 and 1.75. And there's like a little formula that helps you figure this out. So I'm just going to, since this is a distance learning day and it's kind of hard to have you guys guess and check your answers, I'm just going to give this to you. I want you to know that the axis of symmetry. Now, what's true about the axis of symmetry? It splits the graph in half and it goes through the vertex. So the axis of symmetry and the x value of the vertex can be found from x equals -b over 2a. This is the most important thing to remember in standard form. That the axis of symmetry and the vertex can be found from this little formula, x equals -b over 2a. So what I mean by that is if we look at this first equation, this is in standard form because we have an ax squared, this is a, we have a bx, and we have a plus c. So if we do, first of all, without doing any work, we know the y-intercept is at 0, c, so 0, 1. But if we do -b over 2a, that would equal -4 over 2 times 1. Both those numbers come from the equation itself, which gives me 4 over 2, which gives me 2. Which means the AOS is at x equals 2. It also means that the vertex starts with 2. So if the vertex starts with 2, we need to know the second part. We need to know the y value, which means to find the y value, I'm going to take the original equation and I'm going to plug 2 into all the x's. By using my order of operations, parentheses, multiplication, we get -4 plus 1. This gives us -3. That means when we plugged in 2, we got -3. So our vertex is at 2, -3. So, in standard form, things you have to know. The y-intercept is always 0, c. The axis of symmetry can be found by doing -b over 2a. That number that you get, so in this case we got 2, we will always take that number and plug it in to the original. By plugging that in, we're able to then solve for y, which is going to give us the entire vertex, x, y. So, there's a significant amount of work to find the vertex. But our second point, the y-intercept, is easily found without doing any work at all. As we move on to this next problem, you might notice this example and relate it to something we've already talked about. This, I'm going to put a little star next to this. This can actually be considered vertex form and standard form. And I want to show you. In vertex form, we could rewrite it to make it look more obvious. This could be x plus 0 squared minus 8 because it's missing the parentheses or the h value. And in standard form, we could write it as y equals x squared plus 0x minus 8. So it's technically an equation that's in both forms. The reason why is because it's missing the bx term. Now say you didn't catch that. You could still get everything you got by using the same process as what we used in number 1. So just think about it for a second. The y-intercept would be 0, c, and c is the constant. It's the number by itself. So 0, -8. And the vertex could be found by doing negative b over 2a. And since we're missing b, we would use 0 over 2 times 1. And 0 divided by anything is 0. And if we plug 0 back into x squared minus 8, we're going to get -8. So this is a unique example because our vertex is 0, -8, and our y-intercept is also 0, -8. And that can happen. That means the graph's y-intercept and vertex happen at the same point. It's kind of rare, but it can be done. Whereas in the last problem, we had a y-intercept and vertex in different locations. So when you look at number 3, you should be able to tell that this again is missing the bx term, which means the y-intercept can be done without any work, 0, c, but the vertex can also be done without any work. Remember, -0 divided by anything is always going to be 0, so that means when we plug in 0, we're going to get 2, so the y-intercept and vertex are at the same spot. If this doesn't seem to connect with you, all you would have to do is remember that a equals 2, b equals 0, and c equals 2, and you could use negative b over 2a to solve. So if you're not picking up on why the y-intercept and vertex are the same point, just plug the numbers in and do it the long way. Okay, what I'm going to have you guys do right now is I'm going to have you pause the video, and I think it's best if you pause the video now instead of at the end. But I want you to try 4 and 5 on your own. You're eventually going to submit this note sheet. Your note sheet's going to have all the problems that we've done together and also a few that you're trying on your own. So 4 and 5 are going to be done on your own. I think you're at the point where you can accurately find those values. I do want to mention 4 and 5 there is no shortcut for. So you have to actually do negative b over 2a. Notice in number 5 that you're missing your c value, which means it's really like +0. So that's a little hint for you. We're going to move on and we're going to look at number 1 in the next section, which talks about graphing the following. So right away, without any work, we know the y-intercept is 0, c, which is +0 again. So I'm going to go onto the graph and I'm going to plot 0, 0 is my first point. Now I got to do some work to figure out what the vertex and all that stuff is. So I'm going to do negative b over 2a, which is -4 over 2 times 2, which is 4 over 4, which is 1. Which means the axis of symmetry is at x equals 1. So I'm actually going to go to my graph, and I'm going to show at 1 we have an axis of symmetry. Now, right here, right now, we should know if we have a point on the left side of this point right here, we also have a point on the right side of it because that point gets mirrored over, which gives us this point right here at 2, 0. So as of right now, we have 2 points. All we need is a third point, which is going to be the vertex. And remember, if the a value is positive, the graph opens up, which means the vertex has to be somewhere below it so that I get a graph that opens up. Okay, but we need to know its exact location. So whatever number we get from this x equals negative b over 2a, we're going to plug that back into the original. So here it's 1. Order of operations, exponents are going to be the first thing we have to do. Then multiplication, 2 minus 4 gives us -2, which means 1, -2 is our vertex, which is right here. And then I'm going to try my best to draw a U-shaped graph through that. My domain would go on forever, left to right, so it's all real numbers. And the range, it goes up forever. Excuse me. And the lowest point, the lowest y value is -2, including to positive infinity. So, I don't think I need to show you guys another example. I do think that you can go and try 2 and 3 on your own right now. So you're going to try both of those. So, and just to recap here, we started with the point we knew without doing any work, the y-intercept. We then found the axis of symmetry, excuse me, which gave us a second point. We then plugged that value in for x to get a y value, which gave us the vertex. All right, so what you guys are going to do is hopefully you've taken notes, because that is part of your assignment. If you didn't take any notes, you're going to have to go back and copy all this stuff down in your own handwriting. But then you're going to try 4 and 5 and 2 and 3. And once you're done that, you're going to submit the entire thing to On Campus. Disregard this bottom section. We're going to kind of continue with this in our next class. But that's everything we would have covered in a regular class. If you struggle with 4, 5, 2, and 3, we'll talk about those at the very beginning of class on Wednesday. Good luck.